Hey.
Hi, Jeff. Thank you so much for having us
Good to see you.
today.
Thanks for coming today.
Hey, it's good to see you in person.
Clay, we've met on Zoom.
Ivy.
Ivy, glad to have you here,
Thank
Ivy.
you. Yeah, this is so beautiful here, this location.
You know, we've been really fortunate. This location has been absolutely ideal.
Well, we're so excited to see the space today. What are we going to see?
Well, I'm going to show you everything that we have under this roof, which is, you know, development capability, clean room manufacture, injection molding, 3D printing, extensive capabilities, mold making. So you're going to see everything we have to offer. See how it can fit into your development project that we hope we can facilitate for you.
Take my idea to fruition.
That's right.
Let's see what you can do.
So let's go take a look at the lab first, and then we'll continue through the rest.
Great.
So the important thing to note here is that I emphasize development a lot more than I say a design. There are design firms, there are manufacturing firms. Development encompasses the entire spectrum of taking things from concept on the whiteboard and all of the iterations that you go through in order to make a product become reality. And so in this space, we can do a lot of building of prototypes and testing of ideas.
So what happens in here?
So in this particular space, we develop catheter prototypes. This particular area is catheter technology. Over here, we do a variety of other types of technology. In fact, we have something that I can show you. We have permission from our clients, so I'll show you something that we have set up over there in the other side of the lab.
What do we call this space?
So yeah, Jeff, any special capabilities here? I know you mentioned catheters, but what sort of equipment have you had to bring in-house for these specialty projects?
Excellent question. So what's important is to be able to develop things in-house. So if we have to go outside to someone that has a specialty function in their shop, it may cost me 2 weeks, and waiting 2 weeks to get something done drives me crazy. And it drives my clients crazy because 2 weeks is very expensive. And so whatever we can do to facilitate a quick turn on testing and proving out ideas, we do here things. So all over the shelves here, you'll find all sorts of seemingly bizarre stuff. Because we've accumulated stuff over years and years of doing projects, the important thing there is that when an engineer or a client or a technician has an idea, we want them to be able to go into the lab and try it right now. Because if you let it go too long, they may lose it. So what's really critical is to take an idea, go into the lab and test it as quickly as possible to learn the next iteration.
Yeah, and I think, speaking of timeline, right? You learn immediately, you take those results, and you iterate the next one, and there's not the delay of someone else doing it, or there's not the practicalities of when you're trying it on the machine, you see something that you wouldn't have seen if you outsourced it to somebody else. To have those capabilities here are huge. And I already feel pressure from our investors to meet the timeline. So when you say, hey, we care more about the timeline than anything else, I breathe a sigh of relief. Yeah.
So let me show you how the master craftsmen here, the master technicians, might go about building a catheter, and they have so much experience. These technicians are masters of their craft. They've been building catheters of all sorts for 30 years. And so when the engineers have an idea we want to implement, they're the ones that help us understand the reality of what we can and can't do, and they're the ones that build stuff. And so let me show you in closer detail. So here Tony is building a balloon catheter, and so every catheter is made specific to a procedure, which then gets clearance through the FDA to perform that procedure.
So obviously, this is R&D kind of space right here.
Right.
This is not going in human, this is not going probably in animal. Could you build this same catheter once you refined it here and actually build this catheter here to go into human?
Excellent question. So the process would be that here we would prove ideas. And so yes, to answer your question, this would be to iterate ideas.
Sure.
When we have the ideas that we ultimately want to use, we would then take them into our manufacturing space to build the final product that will get used.
And you could actually do that in-house. You could take, I mean, obviously you described what it takes to get to the, clinical version, but you can actually manufacture the clinical version in-house here.
Exactly.
Wow.
And that's why I'm glad you asked that question, because the important thing about what you're going to see through all this is that we take everything from concept through final product, sterile, able to go into patients, clear through the FDA. And we have it all under this roof. So let's go over to the other side so you can see a couple other projects. I do have permission, by the way, to show. I want to be real sensitive to confidentiality, but these are projects that we can show. So the next side of the engineering R&D lab is very much like that, except we aren't doing catheters here. We're doing more mechanical, electromechanical kind of projects. And again, the important thing to see is that we have stuff that we've accumulated over time. Why is that important? Again, having materials that when an engineer has an idea or a client, you never know when an epiphany is going to come to mind and you want to test it. So again, the critical thing is you got to have tools to work with.
Absolutely.
To facilitate the creativity. We have so much stuff. I mean, I know it looks like a bit of a mess. So we let this be this way, by the way. In fact, I encourage this. Why? I worked at places that were so neat and so clean that people were afraid to use the lab.
Interesting.
I don't ever want anyone to be afraid to try an idea. So things can be a bit
Loose.
of a mess here. So here's an example that we've been working on. It's I won't tell what it is, but you can't tell by looking at it. But so we have components that we've purchased. We have components that we have 3D printed in-house. We have components that have been molded. And so we develop, the software to do a specific function, to drive a motor, which has to perform in a certain way. And so the electromechanical work we also do in-house.
Tell me a little bit about your engineers. I mean, in the sense of, okay, yeah, you mentioned you have, software capabilities. How many engineers do you have, and what are their specialties in the range as much as they have?
I think we're at 27 engineers now. And we have electrical engineering, we have mechanical engineering, we have actually an environmental engineer also. We've had biologists on staff, we have biomedical engineers, software. We like to have a broad spectrum of talent. So one thing I'm trying to impress upon them, since you've been here a lot, in fact, this project's been going on for a year or so.
Yeah.
So I want them to appreciate just how closely we collaborate with clients. Again, let's not go into detail on the product, but
Sure.
if you can tell how it's been working with my engineers, I'd appreciate it.
Yeah, absolutely. So we've basically, it started with a need for a very specific design feature to be designed. We didn't have capacity in-house. So we worked with Jeff through references and everything else, and we started weekly meetings, worked with their engineers. We came up with a novel solution to that design feature. And through just naturally what makes sense for the next step, well, since he's designing and building that feature, let's design and build the assembly. Let's package it here. Let's manufacture it here, and it just grows into the full product.
So you guys had a full separate company,
Correct.
didn't have the capabilities in-house.
Correct.
Through reputation, met Jeff and Phoenix DeVentures, started to see the capabilities here, and then started moving more things from your facility in-house here.
That's right.
Amazing.
Yeah.
And how many engineers are you working with here?
We are growing internally with at our company.
Uh-huh.
But when we started, it was 3 of us,
Uh-huh.
and now we're getting up to 25.
Wow.
So it's this past year and a half has been very good, and so that the progress that we've made on the design has obviously built confidence with our investors, and then that's allowed the team to grow.
Congratulations.
So, yeah. Thank
Exciting.
you.
Sounds
Yeah.
fun.
Definitely.
And theirs, I won't tell you about it, but it's an exciting product that's going to, I think, hit the market and
Take
go
off.
crazy.
Hope so.
It's going to
Hope
save
so.
lives. And that's what this is all about, we're saving lives.
Right?
Yeah.
Cool.
Okay, so let's leave the free thinking area and move into the area that is a little more constrained. And speaking of whiteboards, I mean, we just live by the whiteboards here. I can't communicate without a whiteboard, and so you can see when we have a sketch for a tool or a fixture or a product, we're always brainstorming ideas on the whiteboards. Now, what you're going to see here now is our production area, part of our production area. We have 3 clean rooms that we maintain at ISO class 7. So here we do the dental product. We've made well over probably 1.5 million of these things. And then we can do catheters in the back of the room.
Wow. What do we have here?
So this is our 3D printing area. Now 3D printing has almost become ubiquitous in industry now. And so I'll show you some pretty cool examples.
Yeah.
So over here we have plastics printers,
Okay.
and we have 3 different styles of printing.
All right. And what do you actually use these 3D printers for daily?
So every time there's an idea, there comes a time on almost every design when you need to actually have hardware designed, ready to be assembled into something more complex. And so we'll take the CAD, the computer-aided design models, and then we take those files, run them through other software that converts that file to a code
For these?
that these machines can read
And what's that turnaround time from when the machine receives the...
daily.
Daily.
Let me introduce you to one of our engineers. So Jordan is our we've dubbed her the queen of printing. So here's something, for example.
So I can see this being great for iteration, prototyping. What else would you use 3D printing for? So I mean, obviously this is not going to be for large scale production. What's another example that like 3D printing is critical for what you guys are doing?
So the beauty of this of printing is that you can test your ideas readily. You can use them for show and tell when you're going to investors. Instead of just saying, imagine if you will, you can hand them hardware.
Yeah.
And hardware will land an investment much more than waving your arms and showing them numbers, right? And so this is to prove out your ideas, to see if the aesthetics are what you thought they were going to be. Because it's one thing to draw on, it's quite another thing to have hardware in hand to see how it looks. Once you have all the components interacting in an assembly the way you want, and then the whole assembly, as you saw in the lab, completely working, then we could take the designs and make injection molds to make production quantities. But printing has become integral and absolutely necessary to today's engineering process. So another thing that we do here, for example, in this space, we do a variety of things. So this is a general purpose area. Obviously the catheter shafts, but we also do electronic manufacture here. This is a product that we make 500 to 1,000 copies a month it's a blood monitoring system. So we do this here as well. Sometimes this space is used for assembly, sometimes it's packaging. Right now you can see they're packaging product to ship out. Let's go on to injection molding. The typical process back 20, 25 years ago, it could take 4 months, 5 months to get an injection mold made.
Wow.
Because they're very, very complex. And then you get it in and realize, oh no, we didn't include this design feature. So I've always been working at ways to do rapid molding, and so part of that is having molding in-house. So from day one, I've had molding in-house. So now we have a dozen machines in here and 2 machines we use just for engineering purpose. But we'll do a lot of low quantity work. As you see, Tony is, hey Tony, say hi to my visitors.
Hi, Tony.
So Tony now is molding a part. In this case, it's a hand operation.
Okay.
It's often the case that when a product is first introduced to market, their quantities don't justify the cost of an automated tool. So we'll make a mold that we can pull core pins and so on by hand.
Sure.
And yes, the components are expensive, but the mold to automate that process could be a $150,000 mold.
Sure.
But the way we make a mold like this, maybe it was a $25,000 mold, and it gets them into production.
Sure. Proves the market. You can prove the market, and you can reduce costs with automation.
Exactly.
Makes
So we
sense.
do a lot of
better
this kind of
process.
handwork. So the machines we have, for example, we have machines ranging from these small guys, these are 12-ton machines, to 110 ton. Now, what does that mean?
Yeah.
Without getting into what that means to a machine, it means we're going to do parts that are as small as
Okay.
like pop rocks. You know,
Okay.
remember the
Sure,
candy
sure, small.
as small as that, to parts that are about like 8-inch square,
Okay.
depending on the type of plastic that's used.
True.
And all these machines have different characteristics which make them ideal for shooting smaller or larger parts or different types of plastics and so on.
So, what have you seen as far as you have? It feels like there's accountability between your engineers and in the manufacturing. There's a direct line of communication. Does that you see that speeds things up, increases the actual quality of the product?
Excellent question, and in fact, I hadn't even thought about that when you say accountability. So, when we build a mold and then shoot the parts here, the engineer is right on site. Quite often, we actually have clients here on the first day that we shoot their parts because they want to test the parts and see if their design even fits together. And so there have been times when we have actually, fit parts together and find, oh no, this doesn't fit quite right. We need this to be tighter by 5/1000ths of an inch or whatever. We can take the tool right into the shop, make a modification to the tool, and come shoot it again the same day.
So engineer, client, and manufacturer could all be in the same set at the same time.
Yep. Yeah. Now things don't always work that ideally, but
Sure.
that's the possibility, and we have done that. We also have pad printing in house, which is in the back of the space here, so we can print identification on. In fact, let's walk over this way, so I'll show you that. So on these parts, you see some text, some font. It says Flex specifically. So we pad printed that on these components. You take ink and you transfer the image from a plate to this, and that's how, whenever you see plastic, you're going to be spoiled now. Every time you ever see plastic parts, you're going to be looking at certain features because now you see how these things are made.
And it looks like it's actually printed on a curved material, so it's not just a flat print. You can actually print on curved material. Is that what I'm saying?
You've got good eyes. Yes, this is printed on a curved surface, and that's the cool thing about the way pad printing works. It's a silicone pad that transfers the ink onto whatever surface, and it can conform to surfaces.
Interesting.
We do a lot of overmolding also, by the way. Overmolding is molding plastic onto something else. Sometimes it's a hypodermic tube, sometimes it's a stainless steel shaft, sometimes it's another plastic tube, so that we take a component, put it in the machine, the mold closes on it, it shoots plastic around it, so when we take it out of the mold, it's got plastic molded onto whatever that original component is. Most molders don't like to do overmolding. We like to accommodate our customers, so we do.
And that's all in-house?
That's all in-house,
Wow.
right here.
Very cool.
So let's go through to
More toys.
more toys. Oh, I should say that materials. People often ask what plastics can you do, but we shoot all of the common engineering plastics, everything from elastomers, which are very soft, pliable, to much more rigid, high strength materials like Ultem, polycarbonate, and so on. Polyolefins, which are polyethylene, polypropylene. I mean, we really span the entire spectrum. So if your product is going to require some rigid components, some soft components, we do it all.
You've got it covered.
Yeah. So let's go into the machine shop. So we make molds in several different levels. We found it's more efficient for us to focus our mold making capability, which I'll show you in a little bit, on the engineering cycle. And then when it gets to the point where we are building some quantity of product, we'll send out, because we have good shops in Taiwan that we use for production molds, because they consume a huge amount of resource to build production tools. So if you look at molds like this, for example, these are very complex. I'll show you one mold that's pulled open in the shop, But each time you're making a mold, it's like a custom V8 engine.
Wow.
Very complex. A lot of work goes into this, and so we send production mold like this to outside sources so that I can preserve my internal resources for building engineering and prototype molds.
Okay.
And I'll show you what I mean by that
Okay.
in a bit. So I mentioned the complexity of a mold. This mold is
Wow.
very involved. It makes 2 shots at a time, 2 parts at a time, and it's basically shaped like a gun.
Okay.
A plastic instrument that's used in surgery.
Okay.
This is what it takes to make those components in production.
Wow. And I'm sorry, Jeff, you guys built this mold here, or is
This one we had done in
Taiwan.
Taiwan.
Just the labor and so
You know-
kind of designed it here, tested prototype here, and then for large scale manufacturing, for hours spent, sent it to Taiwan.
Correct.
Then they send it back here.
We can do all this stuff.
Yeah, but why would you pay for that?
For me to use my more expensive resources here
Yep.
and limited resources, it would take my shop a month to build this or more.
Yeah.
But if I go to Taiwan, yes, they're going to take
I'm on.
a while to build it.
Yeah.
But because we've already done the prototyping and so on, I can then put my team back on doing the next project while this will be, because there's got to be 500,000 mold makers in Taiwan.
Yeah, we're paying for your brains and then not your brawn, and we're
But what's
using the
the-
brawn where it's cheaper.
But you know, to get this mold made, this mold probably took 3 months to get it here from Taiwan.
Wow.
Yeah.
But like I said, it's like building a
do.
custom V8 engine.
What is it originally?
You know, I've been doing this for a long time, and I was always keen on cutting that lead time to get molds made sooner. So everywhere I've been, I had injection molding, because I've been in the startup industry. I've been with several startups prior to starting this 20 years ago. And I'm always looking a way to get a mold faster. So what we've been doing, and others are doing this also, I didn't originate this, but making a mold like this that we 3D print in plastic allows us to shoot, 20 or 50 or 100 parts
Perfect.
and then throw the mold away.
Me too.
And that is a mold that can be grown, 3D printed overnight.
And sorry, so how much would, if I wanted to print a mold so I could get materials that we couldn't 3D print in, how much would that cost to print that mold? In plastic? That's
We typically do, because it includes the engineering cycle as
Sure.
well, but typically like $2,500.
Wow.
This process has limitations on what materials you can do and the complexity of a component. Because these molds don't hold up, they
Yeah, they're
shatter and they're plastic. But we can print in metal. So for example, this is a printed mold insert, and I'll show you an example of what I mean by mold insert in a minute. So this was printed, this was printed, this is printed, and we can print inserts in metal as well as the plastic, depending on the requirement, with different levels of tooling depending on your budget and your timing and the technical demands of the mold. We've got 5 different ways to make a mold. So the process for making molds, we can grow molds. We can also manufacture them in the traditional sense. We got CNC machines. CNC is computer numerical control. We can take the part as designed. The mold makers actually design the mold. So they do it from soup to nuts. They design the mold and build the mold. So back to the accountability. They are accountable for making their molds that work.
Sure.
And then the engineer right there with them. So they will design the mold, machine the components that go into making this mold, and part of that process requires this machine. So
we
this is called an EDM machine. That's electrical discharge
getting
machining.
close?
Oh, you can just don't inhale this.
Yeah.
So this is what's called, like I said, electrical discharge machining, EDM. The way this works is sometimes there are shapes that you can't cut in a traditional machining operation. So what we do is we then machine an electrode. The electrodes are sometimes made in graphite and sometimes in copper. And we'll make the reverse of the shape for the mold. And then this burns with a high frequency discharge. It's like zillions of lightning bolts eroding the metal out of the mold to create a feature in a mold that we can't cut. And so you actually hear that thing, and you see the sparking taking place. And those are the zillions of little lightning bolts. Every one of those is creating a particle of eroded metal, which is then just flushing out with the fluid. And so the end result is a shape that we just couldn't have manufactured through other processes. So again, this is really a critical space, and so all of our tool makers we've actually trained up in-house. And so I can take a young guy who's mechanically inclined, who grew up with a computer, train them to be a mold maker easier than I can take an old school mold maker and train them to use computers.
So you mentioned before you have 27 engineers.
27 engineers.
in-house.
And a
Mold makers,
total of 60 employees.
60 employees. And then so you have machinists, obviously, in here. How is that distributed? That's obviously manufacturing. How's that
So
work?
we got 27 engineers. Our production crew is, including materials management, is about 15 people, and then we've got the quality group, which is 3 in total of 5 in quality control.
Okay.
And then the shop is 4 people full-time, and then the management staff.
Gotcha.
So one thing, speaking of collaborative mentality, this area right here with this is our smaller conference room, but this conference room and these cubicles we make available for clients to come and use
that's great.
when they need to come and park for a while.
Okay.
So if they're here for a week,
Yeah.
you know, they've got a place to work in the conference room to use and so on. So
That's great.
that works out really conveniently. So that is pretty much it. Any other questions come to mind that
Well,
I
as
haven't
a
answered?
client of Phoenix, what type of relationships do you have in the industry that we could benefit from?
Excellent question. Business is about relationships, you know, and one thing that's really critical to us is our reputation and the relationships we have with our clients. We have never actively marketed or had a sales effort
Wow.
going on. All of our growth has been organic through word of mouth referrals. And so those relationships is what allows that to happen. So when a client comes in and we work with them, what invariably happens, someone comes in and says, I only need to do, you know, some small thing, and then when they come in and see everything that we do, and then they see how we operate, within a matter of a couple months, they have a lot more they're bringing in. So
That's what Kyle said. I mean, when we met Kyle doing
Oh,
the
good
CAD,
point.
that's exactly what he said. I came in for one small task, and then it's grown up, and now we're moving all of our resources over here.
that came in looking for a design and to manufacture just one little component. So those relationships are critical to everything we do, and so we really try to go out of our way to make sure that clients are happy and they recognize that those relationships work and that our connections in industry are going to facilitate their success, because as we say, their success is our success.
Well, thank you so much for taking the time today.
Well, it's great to meet you. Thanks for coming
You
by.
too.
I love to show off our
It's a pleasure.
we call it a toolbox or sometimes toy box.
I could definitely see both.
Yeah.
But
And
it's
I-
all the infrastructure that you'd ever want without having to create it yourself.
Yeah, and I love what we do, and we love servicing customers with clever products. So
Very impressive.
hopefully we can continue working with you.
Thank you.
Great.
Yeah,
Thanks for
absolute
coming.
pleasure.